Right, welcome to another lesson in organic chemistry. This lesson, as I promised last time, is going to be examples and practice at naming branched alkanes. So we're going to have a look at some problems here on the board, and we will see if we can name those substances. So let's have a look. By the way, the homework I set you in the last lesson was how many isomers of C8 H18 there were. Let's try saying that 10 times fast. And it turns out there are 24. So I wonder how close you got. If you don't believe that, look them up. All right, we might see a couple in this practice at naming. Okay, so remember what the first thing is we have to do is we have to essentially identify the parent molecule. Then we have to identify the side chains. They're also known as substituents. Okay, we need to identify the side chains, which are called substituents, and then if we have more than one, we order those in alphabetical order by group name, and there are also priorities for different types of groups, which we'll come to later in our learning. And then we will number from the end to give the lowest possible number. So let's see how we do that here. Right, well, in these examples, we haven't put the hydrogen in. We're assuming there's a hydrogen connected to every free bond of the carbons here, that they are all alkanes. So the first one, we have to find our longest chain, 1, 2, 3, 4, 5. So that's definitely going to be a pentane. I don't see any other chains there, so it's going to be a pentane. Now, are there any side chains? Well, no. What they've done is they've thrown this angular thing in to confuse you, but basically that's just a single straight chain, so the answer is pentane. Let's look at the next one, number 2. 1, 2, 3, 4, 5, 6, if we go along there. So we might think this is a hexane base molecule, but let's just check. 1, 2, 3, 4, 5, 6, 7. So that is the longest chain in this molecule is a heptane. Heptane. Now what we have to do is identify the side chain, and we're going to realize that there is, if we come here, this is our main chain, so our side chain is this one. So that's a methyl group. Meth for one carbon, yl for the alkyl group. It's essentially an alkane with minus a carbon. So it's going to be methyl. So let's put methyl in. The words just join up together. And so we need to figure out which carbon it's attached to. Well, it could be attached. Remember, this is our chain. So 1, 2, 3, 4, 5. That would be carbon 5 counting from this end. Or 1, 2, 3 counting from this end. We always use the lowest number. So we put a 3 in and we join it with a dash. Numbers are joined to words with dashes in this system. Okay? Let's have a look at the next one, number 3. Here we have 1, 2, 3, 4. And 1, 2, 3, 1, 2, 3, 4. So the most we can get from this is a butane. And again, we have a methyl group on the second carbon, 1, 2, or 1, 2. It doesn't matter which way we go. It's going to be on the second. Always choose the lowest, no matter. So the length of the chain that you're counting might determine which is the lowest carbon. So this is going to be a methyl group, 1 carbon, and it is on carbon 2. Join it with a dash. All right, let's look at the next one. 1, 2, 3, 4, 5, 6. Okay, 6 carbons that way. 1, 2, 3, 4, 5, 6. 6 carbons that way. Looks pretty much the same. 1, 2, 3, 4, 5. 5 carbons that way. So it's definitely going to be a hexane. And the group this time is going to be an ethyl group. Doesn't matter which way we go, it's going to be in the third carbon, isn't it? So it's going to be 3 ethyl hexane. So we'll write in ethyl first, and then we're going to put it on our third carbon. It's not going to be the fourth carbon. If we count it from that way, it'll be the fourth carbon. We use the smallest number, so that's going to be 3 ethyl hexane. How exciting! We're going well. We've got 4 out of 4 done so far. We've got a few to go. Here's another one. Again, trying to confuse you by building the longest chain in an awkward way. 1, 2, 3, 4, 5. It's going to be a pentane, I think. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. Yeah, so it's pentane. is the main molecule, the longest chain. Once we take the longest chain out, our extra carbon, the methyl group, is going to be attached to carbon number 2 counting from this end. So it's going to be methyl and a 2 methyl pentane. All right. And finally, well, there's a couple more here to go. Let's have a look at this fella. There are more carbons on here than you'll see in your National 5 exam because this is a 9-carbon chain. Well, there's 9 carbons in this structure. So let's have a look. 1, 2, 3, 4, 5, 6 going that way. 1, 2, 3, 4, 5, 6 going that way. All right. 1, 2, 3, 4, 5 going that way. 1, 2, 3, 4, 5, 6 going that way. All right. This is a little tricky because you could say that this is a substituent chain and it's got its own little branch. But for our purposes today, what we're going to do is we're just going to name this as a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. In fact, what I'm going to do is I'm going to just stick another carbon on there to just avoid confusion. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It doesn't really change anything. So let's say heptane. It's going to be 7. Heptane. And we're going to make it this. Heptane. Okay, now if we're going to take this as my main chain, I am going to have my substituent on carbon 2 and another branch on carbon 3. Okay, carbon 2, carbon 3. So what's this going to be? So I've got a methyl on carbon 2 and I've got an ethyl on carbon 3. Ethyl comes first alphabetically. It comes before methyl. So we'll write ethyl first and then methyl. So let's see. So it's going to be something ethyl, something methyl. It's going to be 3 ethyl, 2 methyl. So this is all tricky. Let's get methyl in. Methyl goes last because it's last alphabetically. Then we have ethyl. Right. Now we separate numbers from words with dashes. So that's going to be ethyl, and the methyl group is on 2. And the ethyl group is on 3. There we go. 3 ethyl, 2 methyl, heptane. All right. Finally, we come to this fellow, which looks rather complicated. Let's see what the longest chain in here is. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Doesn't matter which way we go, it's going to be 4. So it's going to be a butane of some kind. Butane. Now, if I take this here as my main chain, what do we see here? Well, we see that this carbon has 2 methyl groups attached to it. And this carbon also has 2 methyl groups attached to it. Now there's a special thing we do here. We can call a carbon with 2 methyl groups, that structure is going to be called dimethyl. Okay, so there are 2 methyl groups on this carbon and there are 2 methyl groups on this carbon. So we're going to write dimethyl in as the substituent name. Now, I don't need to write this twice. You can see there's dimethyl groups on carbon 2 and dimethyl groups on carbon 3. I could write 2-dimethyl, 3-dimethyl butane, but we don't do that. We just write in the carbons where the dimethyl structures are, and it's going to be 2, 3, and then a dash. And there you go. There's the answer to that question. So I'm going to put a link into your learning, probably in the notes below. I'll put a link in your learning in the notes below to some practice questions on this, and there are some good websites, and there's stacks of information, and it varies a lot because the IUPAC book that details all of this is a big expensive book and not many people buy it, so only chemical companies and people like that have to have it to get it exactly right. So there's a little bit of variation once molecules become really complicated, but there is a set of rules, and there is a set of rules to follow, and some people know them and some people get mixed up like I do. So the best thing to do is just find, I'll link to some websites where it looks like they're doing it right, and you'll get some practice. Okay, so I'm going to say cheerio, and hopefully I've managed to do that in 10 minutes, and I'll see you in the next lesson.